Welcome to part 2 of the Make It Move with SOLIDWORKS series. For this segment, we will take a look at the animation feature. If you missed the first segment on the Make controller, take a look at that video on our TPM Solutions YouTube channel. I'll be using the same robot as last time from First Robotics Team 3506 Yeti as my demo set. I want to animate in more detail how the robot grabs the ball from the ground with the ball grabber, lifts it into the shooter, and fires the ball into the goal. I want to communicate the path of the ball so that users unfamiliar with the concept will understand how the robot transitions the ball from the ground to the goal. With this level of detail, you need to keep one thing in mind. The mate you use will determine how easy or difficult the animation may be to complete. So let's begin making the animation. The animation menu is located in the Motion Study tab at the bottom of the user interface. Before we start following along, I want to draw your attention to the Orientation and Camera Views button. Disable it until you're ready to make an animation step, and I will show you why in a moment. I have a mate aligning the ball to the center plane of the robot to begin, and I have the ball located pretty close to where the ground is. To create the first step, I'm going to drag the animation time bar out to the right to time equals 1 second. I usually create each step one at a time, but you can opt to drag this out to the end of the entire cycle and add all of your steps at once. With the key creation option enabled, I will drag the ball to where I want it to end up after the first second. You'll notice that once I let go, there will be a time key that shows up letting you know that there is a key that has been created. No matter how I move the ball, it only matters where the ball stops when I drop it, and the animation will move the ball from position 1 to position 2 in 1 second. To see the motion, you can calculate the animation and review the movement. It is best practice that while you are reviewing the animation to turn off the automatic key creation button I showed you so that you do not accidentally move an object and create an extra movement. The other reason we disable it is because the view key also saves your camera view, so if you scroll out or move your screen, it will change the view in the animation. To make the animation look smooth and fluid, do not move your camera at all. You can save views by using the spacebar shortcut and making save points of where you want the camera to stay. Starting from where we left off at 1 second, I'll create the next motion, which drops the ball grabber onto the ball. I'll move my time bar out to 1.5 seconds because this action happens fairly quick on the field. Then I will drag the part down onto the ball to create the next keyframe. When the roller spins, it pinches the ball between the bumper and the ball is forced into the ball grabber. The robot can then lift the ball into the shooter using a motor, and gravity settles the ball into place. The ball will need to move with the ball grabber for this to work properly. You can make the time step small to make the ball transition smoothly into position. This takes more time to set up, but as long as you remember to keep your camera in position at the beginning and end of each step, then your animation will be smooth. If it seems as though the animation is too jittery, you can add or remove keys. The larger your assembly is, the longer it will take to calculate the animation. But as you can see here, an assembly with hundreds of parts is animating at a decent pace. I took about 10 minutes to get this animation to move the way I wanted it to, but keep in mind this motion I am demonstrating is fairly complex. I sped this clip up, but it still shows all of my steps. When you're done calculating the animation, you can then save it out as an AVI file. I check the aspect ratio, what portion of the animation in the display area I want to capture, and change the frames to 15 frames per second. The FPS setting can be increased to make higher quality videos, but they will also take much longer to compress into an AVI format. I usually use the schedule button to change what AVI format is used. Most computers can read Microsoft Video 1, but for filming much like I am doing for you right now, I use my own TechSmith Camtasia video codec format. Some additional features you can use in the animation tab are the exploded view, motors, and forces commands. Using the wizard, I can take an exploded view, where I made the ball move in an exploded view step, and stick those into the animation pane. Although I do not have motion of the arm, I can animate on top of that exploded view to create the full animation of the arm and ball. You can add rotation around the model, an exploding view, a collapsed exploded view, the steps from the Make controller, the studies from simulation, to the animation, making this a very realistic and versatile tool. You can additionally use forces and motors to make objects move, but they will not give you any torque or data, which is why I'm going to wait and cover those in part 3 of our series. This has been part 2 of our 3-part Make It Move series. If you missed part 1, go ahead and check that out on our TPM Solutions YouTube channel. Otherwise, we'll see you next time for part 3 of the Make It Move series.